I want to welcome Professor Vijay JANAPA REDDI from Harvard University. His research interests include computer architecture and runtime systems, broadly in the context of autonomous machines, but also mobile edge and computing systems and edge computing systems. And outside his academic duties, he's also heavily involved in the broad outreach of AI for social good. And also maybe importantly in this context, he's also ML Perf Inference Chair. And he will talk to us about the butterfly effect of TinyML. And I'm very curious to see what he has to say. Vijay, thank you for coming, and the floor is all yours.
Thank you, Peter. Much appreciate the invite. So indeed, I was going to talk about the butterfly effect of TinyML. And then I sat down and I said, okay, well, let me get started and see what I can talk about. And very quickly, what I realized is that it kind of took me on a very different path than what I would want to talk to, specifically the students who are going to be presenting. So instead, what I decided was I would totally scramble onto a new talk, which I'm going to call the 10 Commandments for Tiny Machine Learning. And so there are a set of different things that I want to mention as we go through this talk. Specifically, what I want to talk about are issues that pertain to how we think about research and education broadly in this kind of context. And I kind of put the lens on, if I was thinking about it from a student standpoint and I dated myself back to when I was a graduate student, what are the things that I really wish I knew, for instance, or how should I be looking at an emerging field? And so that led me into thinking about like what I'm going to call roughly the top 10 TinyML commandments, that the way I look at it. So this is a very personal opinion. And I'm going to step you through these 10 different things that I've listed out. Now, you may agree with them, you may not agree with them. And I'm totally open to having a debate about this at any given point. But let me step through each and every single one of them. The general takeaway that I want you to have at the end of this 10 list, end of this 10 points, is how to look at this emerging field of TinyML, right? You're all obviously here because you're all excited about it. We're here because we're excited about it. But when we're looking at this particular space, I think there's a certain set of things that we have to keep in mind, starting from the way we look at data engineering. Now, typically when we're doing machine learning, anything around machine learning, right? By and large, where do we all focus? We often tend to focus right around building a model. We have a certain problem that we want to solve, we get very excited about it, and then we want to try and solve that, right? Which means that we end up focusing on, oh, I have some data set somewhere that I want to be able to just download, and then I'm going to just focus on coming up with some sort of new neural network model or new architecture. And then I'm going to try and build a network so I can write about it in a research paper. And I think that's very true for the way things have been in the past, several years. But what I would argue is that increasingly our research, as we look at it, especially in the TinyML context, since it's still emerging, is that we really have to focus on the notion around data, right? Often the data collection and the data pre-processing stage is actually very much overlooked. And in fact, if you look at where most of the enterprises are really spending time, it's around data sets. They're not really spending 90% of the time building the model. They're spending 90% of the time getting the data, cleaning the data, and mostly, I kid you not, based on industry experience, mostly they're reusing the exact same network, just retraining it with better data. So the first and foremost thing I think we all have to keep in mind is really kind of focusing around data engineering. Just the way we had computer science, and then we had electrical engineering back in the day. Over time, we realized building a better computer is actually a very important thing because it has great implications in terms of how things happen in society. Similarly, I think what we're going to start seeing is a new field that's going to come out, which I will say is going to be data engineering, where we really try and understand how to process, how do we go about systematically collecting the data? How do we go about systematically pre-processing the data? And how do we build computing systems that enable us to do this? In the context of TinyML, this is a very interesting space to focus on. I think this is something that we often don't talk about when we do research, but that's exactly where I think we should really be spending most of our time. In fact, Andrew Ng and a couple other people are all talking about it. Increasingly, for the next 10 years, we're not going to be model-centric. We're really going to be data-centric machine learning engineers. So if I was doing research, I would really want to focus on aspects around data. And of course, and then you continue down the pipe. The second thing, often when you're doing your research, one of the biggest things that we often focus around is, again, getting that model to work well. And when we're actually talking about TinyML, one of the really big challenges that we run into is the fact that we actually have to get that model to work well on an embedded device. Now, if we look at the traditional realm of like NeurIPS and ICML, ICLR, all these big conferences, what do we see? We typically see papers where they're focused on models and then building these complex models and deploying them on fairly large systems that are by and large homogeneous. You might say, yeah, B100 is different from a A100 NVIDIA system. Yeah, but still, that's a big, beefy GPU that looks very homogeneous. You write the code in CUDA, and then that thing runs. It either runs fast or runs slow. Okay. Well, it's very different for us in TinyML context because we're extremely resource constrained. So when we're doing our work, if we just go back and focus only on the parts that lead us up into getting an efficient model, right? So we get some data, we train a model, and then we make sure that the model is actually, good in terms of model size, number of parameters, and so forth. But we often ignore this last stage, right, of deployment. Given that TinyML is extremely heterogeneous, where the ISAs on these platforms are very different, where the amount of support that you actually have from the software stack is actually quite heterogeneous across different systems, and portability is not something that we have. I think it's extremely important that we focus a lot on deployment. So the second commandment I would say is that thou shalt not ignore deployment. So when you're writing a research paper or doing experiments, I think showing a small model and claiming it's got good accuracy is not sufficient. We actually have to go all the way to deploying it and making sure it actually works on a given device. The third commandment I would say is that we should not ignore hardware-software co-design. This again goes back to the fundamental point that when you look at any vertical stack in a machine learning ecosystem, it's highly complex, right? Going all the way from the kind of sensors you have to the types of particular applications you're interested in, the data sets you're looking at, the kind of models you might be focused on, the frameworks that are running on a given embedded system. There are many different code paths that you can take, right? This means that because of the extreme amount of efficiency that we're talking about in the TinyML context, we have to focus not just on the hardware and not just on the software, right? It's really about getting the maximum bang for the buck in terms of doing the optimizations across the vertical stack. In traditional systems, again, if you just take the word tiny out of this ML here, right, you would find that in most ML contexts, you would often just focus on some level of abstraction. You don't necessarily try and do co-design, but in the context of TinyML, I think it's actually very important we keep this sort of co-design aspect in mind in order to get the efficiency. The next command I would say is thou shalt not ignore the metrics. Now, very often when we're talking about training models in the traditional world, what do? We look at our training accuracy curves and say, look, my model is finally getting to a point where I'm having very good accuracy. But what does accuracy really mean when you actually deploy it? That's a very different thing. So let's say you're writing a research paper and you're working on some TinyML use case and you say, okay, look, my accuracy, for example, with keyword detection is actually really high. But what's the trade-off? It's obviously about latency, right? You might have a model that's actually fairly complex, and which means that in order to run the model on your embedded device, it'll take longer. So if I'm saying, hey Siri or okay Google or something like that, and of course all my machines wake up when I say that, sorry. If it takes too long to run, but your accuracy is high, I don't know. As an end user, I might not really care about that. That metric of accuracy is completely misguided. Why? Because in a real world use case, you don't just focus on accuracy. You also have to focus on the right metric around latency, right? And you have to put this into the context of a given use case. And often I find papers where they just end up focusing on accuracy and ignore the actual metrics that really matter. So for example, I might be okay with a little lower accuracy, but a much faster model. Why? Because if it turns out that my keyword detection model misses the first occurrence, more than likely I'll say it. In fact, just yesterday, I remember saying, calling Alexa like about 2 times because it wasn't hearing the first one, but the second one picked up. Now, I'd much rather have that than have a model that's super accurate that actually doesn't produce the right, that actually takes too long to execute. So keeping the realistic metrics in TinyML use cases is, I think, quite important because often in TinyML, we're dealing with some sort of, it's not just a machine that's operating all by itself, but there's some aspect of human element in many use cases. The next one is around reproducibility. When we do our research, what do? We often end up just focusing on, do I get the best state-of-the-art result? But is that really enough? One of the problems that we often see is that being able to reproduce numbers in the ML field is extremely hard. In fact, there is a popular quote out there that says like only about 1 in 8 papers or 1 in 10 papers is actually reproducible. Why is that? Well, because you don't have standard benchmarks, or you don't follow standard methodologies, or you don't even write about the data engineering or the data or the deployment process that you chose. And if you don't do that, then building science is all about building on top of prior work, right? So if we don't focus on reproducibility, that becomes a problem. So if you want to understand things around reproducibility, you should check out Perk, which is something that we created, which effectively leads to a set of standardized benchmarks that allow you to kind of faithfully reproduce results across systems and across software stacks or hardware stacks. In the context of TinyML, I encourage you to check out this paper that we just recently submitted to NeurIPS, which is a community-driven effort coming from many different companies all coming together to try and build a standard reproducible benchmark so that we can do faithful comparisons about platform capabilities, different kinds of platform capabilities. All right, the next one, thou shalt not ignore machine learning. You might be a little stumped by this. It's TinyML. So obviously I'm not ignoring ML. Now, we are ignoring ML to an extent. Why? When we're talking about TinyML or just ML at large, often we end up only thinking about deep learning. Now, deep learning might be okay when we're talking about large-scale systems because it's got nice perks in terms of being able to be much more robust to subtle differences in data and so forth, right? However, when we're talking about it from the perspective of TinyML, I think one of the interesting points to keep in mind is that it's going and using deep neural networks is not always the best answer for TinyML systems. Random forests and decision trees and all these other statistical-based machine learning methods exist that are far more efficient than running, an MLP network on something like a microcontroller while trying to do that with about a few milliwatts of power. So the point that I'm trying to say is that let's not all get crazy and go only into deep learning. Let's try and be realistic and look at the problem that we're trying to solve and then try and take a systematic approach as to whether it needs statistical machine learning based methods that are much more efficient to run, or does it really need deep learning? This might sound obvious, but I'm always surprised at how many papers I read which are just about deep learning. And I'm like, I don't even know why you need deep learning for this. Sure, it works, but it's not necessarily the best thing in terms of hardware efficiency. These first few ones, the first 5 that I've listed here, are more technically oriented. These next few ones, though, including the machine learning one, are not so technically oriented, but it's much more from how to think about this sort of ecosystem. So what I say is thou shalt not ignore the industry. Often when you're working in research, one of the biggest things that I often find is that we're all excited about writing papers, right? In fact, what do? We almost measure ourselves by how many papers we have written or which conference we publish in. Little do we ever really reflect on, does the work really mean something in terms of the end value that we're producing? Because at the end of the day, as researchers and scientists and AI practitioners, our job is primarily to move the industry forward. And so what I'm trying to say here is that let's not ignore the wide industry community that we have thanks to the TinyML Foundation, where we get a lot of these different companies coming in. A lot of students often ask me, how do I pick a research problem? They often go and look at research papers and they try and mimic those research papers and say, okay, well, this looks like a hot topic. And so, this is something I should work on. Well, little do you know that by the time that paper actually made it out into the net, it's already about 2 to 3 years old. If I'm publishing a paper today, I've probably been working on it in my head for about 3 years, from raising the money to working on the problem, to actually getting students to work on the problem, to actually teaching them the things, writing the paper, and actually getting the paper out. So by the time something comes out, it's actually pretty old. So what I'm trying to say is that if you're trying to look for interesting problems, look at what the industry is talking about. I mean, we have this amazing resource here, right? That, for example, this exact conference that's going on, it's a wonderful opportunity to look at what industry is trying to solve. And if you look at enough of those talks, you can extract key threads that'll help you identify what kind of research problems are actually interesting to work on. Next thing is thou shalt not ignore the community momentum. A lot of people will often ask me, it's like, oh, how do you sort of know what's an interesting problem to work on? How do you kind of pick from the variety of different things? I used to be stumped when people would ask me a question like that, but often I realized, well, if I was excited about something and I often talk to someone else about it and they get excited about it, or they are themselves already excited about it, then I've found that gravity, that community that you have, which might be just 5 people, 10 people, or 100 people, that community gives you the confidence that you're going out in a new direction and that you might be in fact heading in a useful direction. So try and look at the community and build communities or like working groups around interesting problems you're all wanting to discuss and solve. I like to think that TinyML, one of the exciting things around TinyML is not about just looking at building some piece of technology to say my model is better for this, right? For classifying images in a particular situation. Well, I like to kind of think of what that situation is. And I think like with TinyML, what's really exciting is that a lot of the interesting problems that are out there are actually fundamental needs in the society, right? So what I'm trying to encourage you all to kind of think about is look at what we can do. What are the big problems that we have to solve? And how do we actually get there? And personally, I'm very excited about projects like this, like the Elephant Edge project, for instance. Like we're trying to like do something around building technology for a good societal problem. Also technology around climate change and so forth. There's lots of these real world problems where I think TinyML is really going to be able to make a difference. So, and the last one is don't ignore your own creative ideas. Now the picture on the right is actually a talk I gave back, I think, in around 2015 or 2016, which is called The End of the Road to My Career. It's actually on my website, and it talks about my failures. And when you're a professor, there are certain competitive research awards that you go after. And this is a research award that everybody expects one to receive if you're doing well in your research. Well, it turns out that I was doing something related to mobile computing, which at that point didn't seem like a very relevant thing. When I say at that point, I started the work in 2010. But then, and so I didn't get this award. And well, you think like that caused me to quit. But what I realized is that if you stick with your guns and you believe in some creative ideas that you might have, perhaps like the ones you're about to present, then you actually have the potential to kind of stand out and do your own thing. In fact, I think about 6 or 7 years later, I got this big award talking about exactly the thing that that was getting poo-pooed when I was writing my proposals, which is called the Career Award. So the point I'm trying to make is that TinyML is this emerging area. We don't know exactly where it's going. There's no blueprint yet. There's a lot of excitement. And so if you have creative ideas, run with it. The last point that I want to say is that if you want to try and understand how to systematically kind of think about TinyML, this is a white paper that we just released, in fact, yesterday, which talks about widening access to applied machine learning through the lens of TinyML. It paints a rather complex project that we had done about an edX course, which is available to take, where we try to capture what are the important aspects of TinyML and how do we get this across at a global scale. So there's a lot of technical tidbits in here that I hope you all get something out of. With that said, as Peter and I like to say, the future of machine learning is tiny and bright, and I hope you all have a good time at this event.
Thank you very much, Vijay, for this very nice talk.
Thank you for having me.
I think with that, unless there are questions from the audience, but I don't see any now. No, I don't think there are any questions right now. With that, I think, Andreas, I can hand the floor to you.
Actually,
right?
I have one, Peter.
Good, yeah, sure, go ahead.
Here. I think it's always a pleasure and fun actually to watch your presentation, Vijay, and kind of the stuff you guys do. It's amazing. So I think I wanted you maybe to elaborate on one thing, like you and I discussed in the past, like educating educators. What is your thinking there? How do you kind of go one level below, like the accredited student level for TinyML? I think some people mentioned this during this conference as well. What are your thoughts there?
Yeah, that's a very good question. So, yeah, so when we created the course, it turns out in retrospect, I'd say that any course that we have created so far that's out there is still a pretty big step function in terms of the amount of knowledge you need to have to get into this space. And what we're actually working on as part of it's actually part of the TinyML Foundation effort, which is related to TinyML EDU, TinyML education, is actually creating workshops that can be self-taught by others. So one of the things is that we as academics want, right, is we want to empower other teachers, not just students to learn the material. Real success comes about when other people are actually able to teach it. That's a whole new level in terms of empowering people to learn material. So to do that, we're actually working with Edge Impulse and Harvard and many other folks in the community. We've got a working group where we're actually putting together workshop materials that are just 2 days long, so you don't have to spend like 3 months on it. So there's a progressive on-ramp that we're building that finally gets you from perhaps knowing very little to actually knowing fairly advanced material. in much longer programs. Does that answer your question, Evgeny?
I'm assuming yes.
That's all right.
Still on mute.
Yeah.
Yes, Vijay. Yeah, thank you. Definitely. Sorry, I was on mute. Yeah. And I think the other question, I think what many people ask me personally is, I mean, this course is great, and like what you and many other people do similar, but people bring up an issue of hardware availability. Kind of, what is your answer to that one? Because I mean, in the TinyML, you don't have access to the cloud, right? You need to try things, right? So how do we kind of, what is your solution to that one?
I think so one of the things is obviously having these small kits, right? So we can build these kits, and I think we can work at a bigger organizational level to try and get these kits out into universities. So in fact, just this morning, we had the TinyML working group meeting for education. And one of the things that we are doing is we have this academic network that is globally stretched out, which connects over to universities at many different locations. And at every university, there is a professor who's a champion on TinyML. And so the way we're building this academic network is so that when people are committed to it, then we distribute the kits out to these faculty members who then host the kits locally. And then they can run the workshops. Now, that's one way to just get them to actually have the physical hardware in their hands. Another one that we're doing is simply focusing on TinyML with just doing the TinyML aspects on the phone. You don't necessarily have to have the endpoint device in order to experience the TinyML use case, right? So for example, when you say, okay, Google, well, that's going to work obviously on the embedded system. Well, as you know, we're also running it on an embedded system on the phone, right? So I think that's another level of not necessarily having the kits, but at least using existing smartphone devices to try and get that message across. And of course, the ultimate thing that we're doing is actually complete emulation. So Antmicro has got this complete emulation-based mechanism. And the idea is to be fully free of any hardware and just do it purely in a collab on an emulated Arduino device. And we have those things all running thanks to some of the support that we've had from Google.
No, those are great approaches. Really, they're going to speed up the learning and development. Thank you, Jay.
I have one question, a short one. Vijay, I think I heard that you're running a course that is relevant to TinyML. Can you say a couple of words about that?
Yeah, so the course that we are running, that has been running actually, is the TinyML course, which is on edX. And students can take that course for free to go from understanding basic ML to then understanding applications of ML, and then finally deploying things onto this kit. That's the course we have running. And there's a fourth one that we're actually going to release. It's a bit more advanced when it goes from talking about a single device to actually scaling it out to thousands of devices. But in addition to that, what I was mentioning to Evgeny earlier was that we're also creating these smaller workshops that are more tangible. So perhaps you don't have 3 months of time to just be focusing on it, right? So how do we get within like a 2-day workshop or a 3-day workshop? How can we get someone excited and understand fundamentals? This is not about just doing something. It's actually about having them understand the fundamental principles, for example, like about data engineering. What does that really mean? I think like that bit of pedagogical thing is currently missing from the workshops that we have, but that's an opportunity to kind of work and improve some of the learnings.
Okay, thank you. Thank you.
Thank you very much. And I think with that, then
there's 2 questions.
Oh, there's questions in the chat. I was monitoring the chat.
In the question and answer box, there you can see them.
Ah, okay, good. So one more question was from Christian Tanase is, do you think master's programs that focus on AI and ML could drop out some old-fashioned subjects and replace them with one TinyML subject?
Yeah, that's a beautiful question, Christian. So I think one of the things that we're all realizing as the field is maturing is that ML is actually fairly complex, right? Just the way if you take a computer, it's a fairly complex system. You have people who understand computer science, who are good at the algorithms, who know the big O notations and all those kinds of things. But then there's some of us who actually know computer engineering. In ML, so far, we have largely kind of looked at this as a monolithic block. And increasingly what we're starting to see is that not everybody needs to understand all the math. You don't need to understand chain rule and so forth. I am by no means saying that that is not important. I'm simply saying that there are specialists who need to know that. And then some of us who actually build these systems, just the way a computer engineer knows a lot about how to build the system, but not necessarily running all the algorithms and the complex theoretical notations that are behind the algorithms that are actually running on. So in a similar way, I think what we're going to see is that we're going to see increasingly in master's courses, we're going to start seeing splits like data science versus data engineering or applied machine learning. I think that's going to start happening pretty soon because we're in tremendous shortage of people who actually know how to put things into practice right now. So that's for, that's my answer there.
Yeah. And another question related to also kind of education is from JP Moreale asking about what do you suggest for setting up a pre-university STEM education program?
These are good questions. Awesome. Just this morning, we were talking about the TinyML at the TinyML EDU working group about, we have an effort that's on TinyML for emerging countries. We have an effort around TinyML for K through 12 programs. And one of the things that's come up is exactly this notion of like, is there some ramp that we need to have at the high school level? And so if you're interested, please just ping me via email, and I'm more than happy to bring you up to speed. But there are efforts going on. And one of the challenges, as Evgeny, I'm sure will agree, is just there's such an influx of ideas and energy around it, which is just awesome. And often, I think people find that they come to us, but what I find is that I think we're all bandwidth limited. And the amazing thing is that because there's so little out there in reality, people with ideas can actually do a lot. So one of the things we're trying to do is actually, look for champions. Someone has an idea. How do we help you do things? In fact, the education stuff and so forth, Evgeny was very supportive from TinyML Foundation and saying oh yeah, we should do this. How can we help you? And so I think increasingly many of us, even if we have done stuff, we actually want to help you do stuff. So,
and if I may comment, Vijay, I see this more not as a challenge, as a great opportunity. Really, this is probably the great opportunity for our time to give this technology to people. It's really providing them educational tools like what you're doing, providing them software tools they can develop things, providing them hardware, and then people will start using this to basically do all kinds of things, save the planet, agriculture, healthcare, making their smart homes smarter, safer. That's basically the TinyML Foundation vision, to make a better and smarter environment for all of us. And TinyML is really a key technology to help that.
Yeah. All right, there's a few more in the meantime that trickled in. One is, there's actually two about the edX course on TinyML. One is asking for the link to it, but we can post that as a chat answer. The other one is which background is required for that course?
Yeah, so the TinyML edX course, by the way, don't quote me outside of this, but you can totally take it for free. Just don't tell Harvard that. It is meant to be free. So the edX course was very carefully structured, thanks to a lot of input that we got from external people, where it's 3 courses. And so even if you are light on your ML or you don't know any ML, we actually created the course so the foundations of TinyML actually onboard you with introduction to embedded systems, introduction to fundamentals of just machine learning around convolutional networks, MLPs, and so forth. And then the second course then really gets into the applications of TinyML before you go to deploying, where, yeah. So the requirements are actually intentionally kept low. So at best, you need Python in order to make your way through all the way through course 2, and finish course 2. It's only in the 3rd course where you might need a little bit of C and C++.
Yeah. That's good. It's very accessible for everybody then that way. Then one also from Vikram Janwal was on your education initiative. Would you be interested in extending that also towards industry?
Yes, that is also a very good question. The answer is absolutely yes. One of the ways that I've been thinking about is when it comes to industry, there are two segments. There's a set of there's an interest amongst the engineers who actually want to know the bread and butter kind of thing, right? How do I train and deploy these models, and what are the nuances to look out for? That's obviously got all more advanced than the edX course. And I think I see an opportunity there. That's one. So yes, I personally am interested in this. And then there's another one, which is the people in the management level. Now, they don't necessarily need to understand nuts and bolts of what's going on inside like STM-Cube-AI or like TensorFlow like Micro. They don't need to know that, right? But what they do need to know is when the engineers are building those things, they have an appreciation of what the engineers are telling them about. And I think that's about understanding where the space is going, why there's so much potential around this, and why this community is growing so fast. And I think that's a very different type of education, because you're trying to educate them about the implications of this technology and why, if, for instance, they miss the boat, they're definitely going to miss the boat, right? I think these sorts of technologies are like a double-edged sword for companies, right? If they miss it, then they can lose the edge. So yeah, very interested in those things. Again, I would be very happy to talk to anyone interested in those.
Excellent. And then there's one more from Gregory Ahua, who just started his PhD on application of edge processing on industrial use cases, and he was looking for a few words of advice to getting to know more about the TinyML ecosystem.
I think TinyML ecosystem. Well, you're at the right place. This conference is awesome, and I think the way, for instance, if I was a student, to be honest, the way I would look at this, because sometimes there's so much going on that it's really hard to navigate. And being a teacher, I mean, I understand that firsthand because I'm dealing with students all the time. I think as much as we provide from the industry side and the top down, we provide all these umbrellas, it's a little intimidating to actually step into a space that is moving so fast. So the way I would kind of look at it is, again, focus. If I was to be strategic, I'd say focus on the keynotes. The people who are giving these keynotes are really good. And they're good not because they know stuff, but they know how to communicate the interesting points that are actually important to look at. And if you can understand how to listen to those keynotes carefully, that will usually tell you where some of the interesting problems to solve. And I think just generally just looking at the TinyML website, there's a research symposium that we have started under TinyML. That's a place we're trying to incubate more of the far-fetching research ideas, while the main TinyML Summit kind of hosts the actual industry talks. I think so. Looking at the last year's research program will also kind of give you an idea that, okay, there's momentum in this space. You're early to the race, so you might not necessarily get all the answers, only because things are still cooking.
All right, I think that was it for all the questions. I don't see any new ones rolling in. I also think if you want to look at what's happening in the ecosystem, what has been happening, if you look on the TinyML website and on the YouTube channel, a lot of the past talks are also posted there. So that's a very good resource to dive into specific topics even deeper. And I think then, thank you, Vijay, for all your time in answering also all the questions. I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm, Sentient, and then our platinum sponsors, we have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMSA, Greenwaves, HOTG, Imagimop, GISO, Seed, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you everybody for contributing. Thank you, Andreas, for also moderating this session.